Hi everyone, and welcome to our video on simplifying fractions that involve trig functions. So all the ones above are algebraic ones, but they follow the same procedure that these bottom ones do that have trig involved. So for instance, in number 1, we can squeeze that in. Usually when you have a monomial down in the denominator, so a single term, it's really best to separate it into two different fractions with the same denominator in both. Okay, so this is like the reverse of getting a common denominator. So we're splitting the fraction up, and then that way we can see, oh, this x divided by x would be 1, and then on this problem, well, 2 over x will just leave. Okay, however, with the trig function, we can do a little more to it sometimes. Okay, so same deal. This is a single term down there, so we should rewrite each term in the numerator over that single term. So cotangent of x over cotangent of x minus 8 over cotangent of x. Again, it's the reverse of a common denominator. So, and let me do a side example to further kind of state what that means. So for instance, like if we had 7 tenths plus 2 tenths, we know 7 plus 2 is 9, and then the common denominator is 10. Okay, so we usually just do that step right away. But instead of doing that step right away, let me erase that. We can say, well, let's show 7 plus 2 like that. And then what we're doing in these problems is we have variables. So we're starting with something like this and working our way this way. Okay, so we can see, oh yeah, there's that 7 over 10, and then, oh yeah, there's that 2 over 10. Okay, and we already know again that that was 9 tenths no matter how we calculate it. Okay, so with numbers, we can see it maybe a little better, but the variables follow the same rules. All right, so that's why we can do this back down to here, number 4. Let me put my equals, so we're back here. Okay, and the reason that we wanted to separate it is, well, cotangent of x divided by cotangent of x, the same thing divided by itself is 1. And then minus, here's where we can use a reciprocal identity that we've seen in the past. Remember that the reciprocal of cotangent is tangent, so we can rewrite it to make it look at least not like a fraction. Okay, so the 8 over cotangent of x is the same thing as 8 tangent of x. Okay, so we know that 1 over cotangent of x is tangent of x. And also we know 1 over tangent of x is cotangent of x in case we need that. Okay, so that was our reciprocal identity. Okay, anyway, so at least rewriting it, it doesn't look as bad. Okay, so it started with a big fraction. Now at least it doesn't look like it. Okay, number 5. Number 5, here we have two separate fractions, and so we probably want to combine. So usually if we have a single fraction like 1 and 4, we split up one big fraction. But with 2, 5, 3, and 6, they already are separate fractions. We usually want to combine. So combine into a single fraction. That's usually how the pattern goes with these style problems. So I'm saying usually a lot because we don't know for sure, but it's often a good idea to do that in our problems coming up. Okay, so on number 2, whenever you have separate fractions that don't have the same denominator, what you can do, it's kind of like cross multiply. I'm going to say these two, I'm going to connect these two. Let's put a big dot. And then take the bottom right and make sure that it also multiplies the top left. Take the bottom left and make sure it multiplies the top right. Okay, so we would have x times x minus 4 times x plus 2. And then the bottom, the big times, would be x plus 2 times x. Okay, so that's a way to get a common denominator quickly. So let's try that with number 5. And then number 2, we would continue simplifying, but let's do it on our trig stuff. I just wanted to show the first step. So on number 5, we would say, well, these two need to multiply, while simultaneously this cosine of t also multiplies the top left. the sine of t multiplies the top right, and keep whatever the sign is in between the two fractions the same. So that means we've got, let's get a big fraction going. 3 would times cosine of t, and then plus 5 sine of t would multiply sine of t. And then down below we said, oh, the sine of t should multiply the cosine of t. And there I'm using parentheses. It's fine doing that. I think it's a good idea a lot of the times. And then now in this step, let's clean it up. So in our numerator, 3 times cosine of t, we don't need the parentheses there anymore. Let's just say 3 cosine of t, and then plus sine of t and sine of t, same thing times itself. That would be sine squared of t, and then the 5's still just hanging out. The 5 is chilling, it's waiting. And then down below, sine of t times cosine of t, those don't get along, so just rewrite them as sine of t times cosine of t. There we go. There's our big old fraction rewritten. Okay, so that's one way to try to treat these problems. Again, we're about to do a lot more algebra with different things. These are to really help us with those. Okay, number 3. Again, same deal. Let me just set it up and not actually write this top one. We would say, because they're not common denominators right now, we know these two need to multiply down below. And then let's use parentheses around each of those numerators. The x plus 3 would multiply the top left. The x minus 3 would multiply the top right. And just like before, let's set up that thing but not fully do it. Okay, so we said x squared minus x would multiply the x plus 3, and then still a minus sign. The 2x minus 3 would multiply the x minus 3. Okay, so that x minus 3 on the bottom left multiplies the top right. And then the two denominators multiply x minus 3 and x plus 3. Just like that. Okay, so that would be the big setup. And then afterwards, do some simplifying up top. So we would distribute and then combine like terms. Okay, so a few more steps there that won't be able to fit here. But I want to focus on the new stuff, the trig. So same deal. Let's set it up with the big parentheses here and here. And then these two would multiply, while the bottom right also multiplies the top left. And the bottom left also multiplies the top right. Okay, so we've got big fraction, 2 would times 1 plus sine of theta, and then minus 1 times 1 minus sine of theta. And then down below, it's the same big old multiplication that is shown, 1 minus sine of theta times 1 plus sine of theta. And then now let's simplify the numerator. So this 2 distributes. The negative 1 would distribute. So we have big fraction. 2 times 1 is 2. And then 2 times sine of theta is 2 sine of theta. And then negative 1 times 1 is minus 1. Negative 1 times negative sine of theta would be plus sine of theta. Now the denominator, it might be a good idea to FOIL that out or multiply it out. However, a lot of times we leave the denominator in factored form, which it currently is in. Okay, so sometimes it's better to multiply it, sometimes it's not. I'm going to leave it in factored form. And then my last step is to just simplify by finding like terms in the numerator. So we have a 2 and a minus 1. And then we have a, let's do that in pink. We have a positive 2 sine theta and a positive sine theta that would also combine. And so for our final answer, big fraction, 2 minus 1 is 1. 2 sine theta plus 2, just sine of theta. So 2 sine of theta plus sine of theta would be 3 sine of theta. And then again, the denominator, I'm going to leave factored in the factored form. So maybe multiply it. It depends on the problem. So we might need a few more steps. Again, it will always depend on what we are looking at. But for now, I'm going to say that's usually what we do. Okay, so there's our fraction stuff. Okay, so the next things that we're doing is usually just combining all 3 of these strategies to help us with simplifying trig expressions. So we see, oh, there's a lot more down there. Okay, so that's our next video. Okay, so thanks for watching. If you have questions, please let me know.